Hello, in this video we will be solving the maximum power that can be delivered from a voltage source when we're using phasors. So by looking at the diagram in the top left corner, we can see that we have an unknown load, ZL, and we also have another load connected in series that has a resistor of 1 ohm and an inductor with an impedance of 2 ohms. We also don't know what the current is, so we'll be solving for the current, the impedance, and then there's a second part that will be going through after we solve for the maximum power. So to start off, we need to understand that in order to be able to deliver maximum power, in this case, ZL would actually have to be equal to 1 minus 2J. And the reason why it's 1 minus 2J is because we're using a negative 2 to oppose the 2J here by adding a capacitor in series, so that we end up having only real power between the 1 ohm resistor and the 1 ohm resistor from the other side. And also maximum power will be delivered when the loads are split in 50%. So now we can solve for the current amplitude using the amplitude of the voltage divided by the total resistance in this circuit. So we know R plus R2. So that would give us 10, which is the amplitude here of the voltage, divided by 1 ohm plus 1 ohm, which would actually give us 5 amps. Now, there's two different power equations that we can use for power maximum, and we know that power can either be solved using the amplitude of the voltage multiplied by the amplitude of the current, or it could actually also be solved by the amplitude of the current squared times the resistance. So if we use either, we will get the same answer. So if we go by 10 volts times 5 amps, or we get 5 amps squared times the total resistance of 2, we would end up getting 50 watts. And you can check that in your calculator if you want. You go 5 squared, that's 25 times 2, that will give you 50, and that's your maximum power delivered. Now there's a second part here, which the question that I pose is, out of these four potential diagrams, when we know that our circuit's load is an RLC, right? We have a resistor, we have an inductor, and we have a capacitor. Given these four different options of instantaneous power, which one is not possible to have? If you want to think about it for a little bit, you want to ask yourself, what would determine, in what case would instantaneous power of these not be possible? You have to think about it in terms of average power. So if you have your instantaneous power, right, which is power like these that is changing, you have your average power. Your average power would just be taking your instantaneous power over a period, and that would be your average power. So in the first case, your average power would look something like this. It would be a line that is the average of this graph, and it's a positive number, as you can see. In the case of B, it would be actually at 0. In the case of D, it would be a little bit lower than the first one, which let's call it A here, and let's call this C. So D would have an average power that's a little bit lower than A, but in the case of C, you have a negative average power. And the reason why you cannot have a negative average power over a period is because your resistor does not store energy, therefore it cannot release energy to other components of the circuit, and that's why you will not have negative average power. In the cases of inductors and capacitors, you might think that, okay, they do store energy and they do release energy, but over a period, they do not release more energy that they gain in the circuit that we had above. Therefore, C is not possible. Thank you, and I hope you learned.